Hey there, math students. In this video, I am going to go over 31 sample test questions. And these types of questions will help you with a wide variety of tests. For example, the GED Math Test, it'll help you with those types of problems. But it's specifically designed, these problems, for the HISET test, which is the high school equivalency test. But again, if you're taking the GED Math Test, this will be helpful as well. Now, for the HISET test, there are a total of, 55 questions, and you have 90 minutes to do it. So let's just jump into this. First question, it says a picture framing shop has the sign shown below in the window. Frame sale, half off 17-inch by 24-inch frames. Now, a customer has a 4-inch by 6-inch picture. If the customer wants to enlarge or make bigger the photograph so that it will come as close as possible to fitting a sale frame, how many times larger should the photo be? I am going to underline my final question right here. How many times larger should the photo be? Now I know what my answer choices mean. This means 2 times larger, 3 times larger, 4 times larger, and so on. And it also has some information here. It says as close as possible. That means my answer is not going to be exact. It'll be really close. Now, I have a 4 by 6 inch picture right here. And the sale frame is 17 inches by 24 inches. Let's draw a picture. I'm a visual person, so let's draw a picture of the sale frame. Something like this. It's 17 by 24 inches. That's the dimensions of the frame. And my picture is 4 inches by 6 inches. Something like this. Four by 6. So I need to enlarge my picture so it fits inside this frame. Now, it doesn't talk about the cost anywhere, so don't let this half off confuse you. We don't need that information. So let's see. What I'm going to do now is use my answer choices to help me. This says, does my picture frame, which is 4 by 6, need to be 2 times bigger? Well, let's check it. This tells me to multiply the dimensions by 2. So I'm going to multiply this by 2. And this by 2, and see if it matches up with these dimensions, or as close to it, because it says close as possible. So let's see, 4 times 2 is 8, 6 times 2 is 12. So now the dimensions of my picture are 8 by 12. Yeah, that doesn't really match up very closely with 17 by 24. So A's gone. So I'm going to get rid of A. Let's try B. 3 times larger. Let's see, times 3 times 3. This is 18. Well, let's start down here. 4 times 3 is 12. 6 times 3 is 18. So now it's 12 by 18, and this is 17 by 24. It's getting closer. I'll leave B in there, but it still seems not quite right. Now, while I'm working through this, you should notice there's one answer choice for sure I can eliminate. Hopefully you can see it's E. I mean, 6 times 13 is much bigger than 24. So while you're working through the test, if you can eliminate certain answers, it increases your chances of guessing. So E is definitely gone. Now, I tried B. I'm going to leave it, but let's look at C. Let's multiply by 4 now. So I'll take this times 4, and I'll take this times 4. 4 times 4 is 16. 6 times 4 is 24. Look at this. Now they match up perfectly. The 24 and the 24. And the 16 and 17 are almost exact. And it said as close as possible, it's going to have to be C. And I move on to the next question. Question 2. Consider the advertisement below. Sale, paper sale, $25 per box. 5,000 sheets per box. Which of the following expressions represents the cost in dollars of 20,000 sheets of paper? So I like to look at my answer choices always first to see if there's anything I can eliminate right off the bat. I can't see anything really clearly. Maybe B I could get rid of, but let me just work through this problem. I'm a visual person. I want to draw a picture of this. So it says there's a sale and it's $25 per box. So I have a box like so. And this box is $25. Now what's inside the box? It says there's 5,000 sheets per box. So inside this box there's 5,000 sheets. Now, I want to know which of these expressions represents the cost in dollars of 20,000 sheets of paper. So let's draw out the rest of this model. Hopefully you can see that if we have 5,000 sheets in one box, the cost is $25, but there's the cost is $20,000, not $5,000. So hopefully you can see that we're going to need 3 more boxes. Let me just draw that out for you. You'll see it visually this way. I'm going to draw 3 more, and you'll see why in a second. You might already see it. Remember, there's 5,000 sheets in each box, so I'll put 5,000 sheets here as well. 5,000 sheets here. 5,000 sheets here. Hopefully you can see that that is 20,000 sheets, right? 5,000, 10,000, 15,000, 20,000 sheets. And each box costs $25. So what do you think the total cost is going to be for 20,000 sheets? Well, we just add up the $25. It's 25 plus 25 plus 25 plus 25, which is $100. So whichever expression here gives out a cost of $100 from here, that will be my answer. Let's see if we can eliminate some off the bat. I can eliminate this, B. I mean, 20,000 times 25 is way bigger than $100, so this is gone. I could eliminate some more too, I can see, but let's just go ahead and get our calculator out. You'll have access to a basic calculator. And let's just start with A and see when I punch this in if I get out $100. If I do, A is my answer. So, the way you punch this in, this is 20,000. This means division divided by 5,000 times 25. So I'll just punch that in. 20,000 from here divided by 5,000 times 25. And the first answer choice gives us 100, so I'm done. So when I punch this in, I got out $100, which matches up with this. So A has to be my answer. I circle A, and I move on. Question 3. Which of the following sets of data would be best represented by a circle graph? A circle graph looks something like this. And what it does is it takes a total of something and breaks it up into different parts. And these parts are usually labeled with percentages. Circle graphs are not good for measuring changes over time. So basically what I'm going to do is go through each answer choice, and anything that talks about changes over time I'm going to eliminate because circle graphs aren't good for that type of measurement. So let's look at A. Is there anything about time in here? No, it says the percent of United States immigrants from different continents. What about B? No, the life expectancies of various animals. That doesn't mention time in it. But what about C? It says college tuition increases over the last 5 years for a state university. You would not want to use a circle graph to represent this data because it talks about time, measurements in time. So I'm going to get rid of this. Do you see any other answer choices we could get rid of? Hopefully you can see we can get rid of D because it has a measurement of time in here, the last 6 years. And E as well, it says over a 1 month period. Now I've eliminated 3 answer choices. I'm down to 2. At this point you can guess, you have a better chance of guessing and move on. Remember, you don't have that much time on this test. However, I'm going to narrow it down to the final answer because I know circle graphs deal with percentages almost all of the time. And it says right here the percent. So probably my answer is going to be A because of this word. B doesn't have that. But in reality, another way to look at it is this would be easy to make a circle graph of A because you can take the total United States immigrants and you can break that total up into different continents. So that would be ideal for a circle graph. And B, I'm just going to eliminate it because it didn't have the word percent in it. I'm not going to get into too much detail as why this wouldn't work. So that's a great test taking strategy I did right there using the process of elimination. Question 4. If 6 bottles of perfect water weigh a total of 4 kilograms, what is the weight of 9 bottles? Let's highlight this final question here. What is the weight of 9 bottles? So, do 9 bottles weigh 5 kilograms, 6 kilograms, 7 kilograms, and so on? So, let's work through this. Again, you want to see if there's any answer choices you can eliminate. I don't see any off the bat, but you might. But I do know it says that 6 bottles weigh 4 kilograms. So 6 bottles weighs 4 kilograms. Now, what would 3 bottles weigh? I mean, if 6 bottles weigh 4 kilograms, I want to know the weight of 3 bottles. Well, 3 is half of 6. So let's take half of 4. That's 2 kilograms. Hope that makes sense to you. I'm just saying, okay, kind of, let's not lose our common sense here. If 6 bottles weigh 4 kilograms and I have half the number of bottles, then 3 bottles must weigh 2 kilograms. I just took half of each one of these are divided by 2, right? I divided this by 2, I get 3. I divided by this by 2, I get 2. And look, now watch. I can just finish this up. I have 6 bottles and 3 bottles. If I add that up, I'll get 9 bottles weighs, I'll add these up, 6 kilograms. So that's one way to go about this. You can set up a proportion and do this mathematically, but I saw that pattern. I like it this way. So the weight of 9 bottles is 6 kilograms, which is B. Question 5. A tourist's cab fare was $12.89. If she would like to give the driver a tip of 15%, approximately how much money should she give as a tip? So this is just a percentage problem. I'm going to leave a tip of 15%. And here's how I think of percentage problems, at least these types. I think to myself, I'm going to leave a 15% tip, 15% of the total. Well, the total was $12.89. So 15% of the total, $12.89. Well, of in these types of problems means multiplication. So it just comes down to 15% times of becomes multiplication, $12.89. Now I just need to punch this in on my calculator. I have a basic calculator, and you need to remember that percent means out of 100. That's what this means, per every 100 are divided by 100. So I'm going to rewrite this as 15 divided by 100, because that's what 15% means. 15 out of 100 times 1289. Well, let's do this. Let's see. So 15 divided by 100. I'm going to hit enter. You don't have to. You can just hit times right away, but I'm going to hit enter first. Or equals, and then multiply that by 1289. And I get, let's see. Well, let's see. I'll write the whole thing out. 1.9335. 1.9335. Well, we're dealing with money, so I'm not going to include this piece here. It's $1.93. Well, it says here, approximately how much money should she give as a tip? So not $1.93 is closest to, which one? C. So my answer is C. Now remember, when you're working through these, I recommend, when it makes sense, to underline that final question, which I probably should have done here at the beginning. How much money should she give as a tip? So these represent our tips. Should do this at the beginning. So should I leave a $1 tip, $1.50 tip, a $2 tip, and so on? So I'm leaving a $2 tip. It's important to underline that final question so you know what your answer choices represent. And you should always look here as well to see if there's any answer choices you could eliminate. Because a lot of times there are, not really in this one, but maybe you could have seen one that you could have eliminated. Well, let's go to the next one. Question 6. The floor of a 15-foot by 20-foot rectangular room is being covered with carpet tiles. Each carpet tile covers 6 square feet of floor. Which of the following expressions represents the number of carpet tiles needed to cover the entire floor? You can underline or highlight your final question. I'll highlight it this time. So I basically want to know which one of these expressions represent the number of carpet tiles needed to cover the entire floor. Well, let's draw a picture. We have a floor that's 15 feet by 20 feet. So we'll say this is 15 feet by 20 feet. Now, I have these carpet tiles that are 6 square feet, something like this. Make it a little bigger because I want to write a 6 in there. So they're 6 square feet. I'm going to put these carpet tiles, they have carpet on them, onto the floor here. Well, the question comes down to this. How many of these 6 square feet carpet tiles can I put inside of here? How do you think you'd figure that out? In other words, I got to figure out how many of these little 6 feet tiles, carpet tiles, I can put to cover this floor completely. So now we have a visual understanding of what's going on. That always helps me. I think the first thing I'm going to do is just find the area of this floor. So to find the area, you take the length times the width. I interchange length and width. Technically, in reality, length is the longer side, so you could say length times width. It doesn't matter. You can mix those up. I'm basically taking the 15 feet times the 20 feet. That'll give me the area. You'll have access to a basic calculator, so let's do that. 15 times 20. Well, that's 300. So this whole thing is 300 square feet. I'll put in square feet here. And I'll put in square feet here. This is really 6 square feet because it's a little kind of square. So the question is how many of these 6 square feet tiles can fit inside this 300 square foot floor? what do you think I would do? Well, let's just draw some if you're not seeing this. I'll make it a different color here. We'll say this is 6, and then this is 6. This is 6. This is 6. So this would be 1, 2, 3, 4 square tiles. And what's 6 plus 6 plus 6 plus 6? Well, that's 24, right? That would be 24 square carpet tiles. But I can fill up 300 square feet. So I could just keep counting 6s to see how many 6s fit inside this 300. There's nothing wrong with doing it that way, except it's going to take some time. When you're dealing with problems like this, you can use division. You can just figure out how many 6s can I pull out of 300. So you can just go 300 divided by 6. So I'm taking this number and dividing it by this number. I'm seeing how many 6s can I pull out of 300, or how many 6s can I put into 300. Same thing, and what's that going to be? Well, 300 divided by 6 equals 50. So I can fit in 50 of these. 50 carpet tiles. That's really the answer. Now, if you don't believe me, draw in 50 of these, count them up, and when you add it all up, you will get 300. However, they gave the answer in terms of expressions, and we have the exact answer of 50. So whichever one of these expressions gives us 50 right here, whichever one of these equals 50 is going to be the answer. Well, I can eliminate A. 15 times 20 times 6 is much bigger than 50. That's gone. B, what's 20 times 6? That's 120 divided by 15. I'll keep that. I'll keep this. This one's I can get rid of. I can see this is going to be a fraction. So I can probably get rid of D. If you don't see why I got rid of it, just punch it into the calculator, and you'll see you won't get this, but I'm going to eliminate it. And let's just try these three and see which one gives us 50, and then we're done. Okay. So we have, this means 20 times 6. This is division divided by 15. So 20 times 6, right, divided by 15. That gives us 8. That's not 50, right? This was 8. It's got to come out to 50 carpet tiles. This gives us 8 carpet tiles. That's gone. All right, let's try the next one. 15 times 20 divided by 6. So 15 times 20 divided by 6. That's 50. So this gave us 50. That matches up with 50 here, and C is my answer, and I move on. Question 7. Which of the following graphs represents the relationship between variables x and y if a decrease in x is always accompanied by an increase in y within the given domain? I'm going to cross this part out here, within the given domain. That's just your possible input values. You don't really need it for this problem. The big piece is right here. Which graph represents the relationship between variables x and y if a decrease in x is always followed by an increase in y? In other words, which of these graphs shows a decrease in x, and decrease means to go down. In other words, when x goes down, y goes up. Is it graph 1 only? Or is it graph 2 only? Or is it graph 3 only? Or perhaps it's both 1 and 3, or perhaps it's all 3 graphs show that relationship. Well, let's go ahead and work this through, and remember your x values are along this axis, right? It says x, and your y values are along this axis. Now, I'm going to put in some numbers here to make it easier to understand. So how about if I put a 0 here, and I'll count by 2s here. 2, 4, 6, 8. Why did I count by 2? I don't know. I felt like counting by 2. You could count by 1s if you want to. And I'm just putting in numbers to make this easier to understand. And I'll call this 2, 4, 6. Now, I want to know if the following holds true with this graph. If x decreases or goes down, does y increase and go up? Well, let's just start with 8 over here because I want x to decrease. So I'll start with my bigger number and I'll move from 8 to 6 and so on. So let's start with 8 and let's see what the accompanying, that's a tough word to say, y value is. So here's 8. I'll go up till it touches the graph. I'll make a point. The accompanying y value is 2. Now I started with 8 because I want x to decrease. So now I'll decrease x. I'll go to 6. What's the accompanying y value? Well, here's 6. The accompanying y value, go up till it touches the graph, make a point, and the accompanying y value is 4. You should be able to see right here from those first 2 points that as x decreases, it went from 8 to 6. Y increases. It went from 2 to 4. Hopefully you can see that visually, but if you can't, let's make a table. And let's do one more point just to make sure you got this. Let's skip 4. Let's go from 8 to 6 to 2. And before I do that, let's fill in the table. So when x was 8, let me make a little better table here. When x was 8, the accompanying y value was 2. When x was 6, we decreased x to 6. The accompanying y value was 4. I skipped 4. I'm being lazy. That's why let's just go to 2. Let's see. What's the accompanying y value when x is 2? And I'll put 2 in right here for x. Let's see. I'll go here and then I'll go up. And the accompanying y value is 6. I'll put my point there. So when x is 2, y was 6. Now you can see it from the table. Does this graph show a decrease in x is followed by an increase in y? Oh, if you can't see it from the graph, you can see it from the table. A decrease in x. Yep, x is decreasing. 8, 6, 2. It's going down. Is that followed by an increase in y? Well, let's see. Y went from 2 to 4 to 6. Yeah, y went up. It increased. So this graph shows that when x decreases, y increases. You can see that from the graph and the table. So graph 1 works. So I know my answer choice has to contain graph 1. Let's see. A contains graph 1, so I keep it, right? Anything that doesn't contain a graph 1, we get rid of. B's gone because it says only 2 works, but we know graph 1 works, and C's gone because it says only graph 3 fits this description, but we already have shown that graph 1 works. Now, D and E we need to keep because it has graph 1 in it right here. So now if you need to guess, you can guess. You have a better chance of guessing. Now, what we have shown is that a graph that slants in this direction is going to fit this description. Let me explain. When I'm teaching algebra or math, I always tell students to read graphs from left to right. From left to right. And that's especially true if you want to figure out if the slope is positive or negative. But this one I'm going to read in the other direction because we started with x over here and we decreased it. So for this, just this particular problem, I'm going to pretend I'm standing here. And what we have shown is that if I walk in this direction, when x decreases, y increases. So keep that in mind because that's going to help us eliminate graph 2. Again, we're reading, I'll put in some numbers real quick, just really quick. 1, I'll count by 2s, 2, 4, 6, 2, 4, 6. Now again, I'll put 8 here as well, like I did here. We want a decrease in x, so we started over here, and we decreased x. So I'm going to start myself here. I'll put myself in green again. Right, that's me. This is slanting in the other direction. It doesn't matter that it's curved. Don't let that throw you off. This is if I start over here, I'm kind of walking up this way. But if I start over here, I'm walking down. Again, it doesn't matter that it's curved. This one does not work because it's slanting in the other direction. And you might be able to see just by looking at the graph that as x, I'll put it here, as x decreases. See, if I go from x is 6 to x is 4, y will decrease as well. So when x goes from 6 to 4, boom, 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 y went from 8 to 6. So this graph shows that when x decreases, y decreases. When x goes down, y goes down. And you can get rid of it. Graph 2 doesn't work. Now, you didn't need to go through all this work. You might have seen that right off the bat. So let's get rid of anything that contains graph 2 is gone because graph 2 doesn't work. So let's see. I can get rid of E because E says graph 1, graph 2, and graph 3 fit this description. We just showed that graph 2 doesn't, so E's gone. Now I have a 50-50 chance of guessing. Let's go to the last one. I can tell you right off the bat for graph 3 that this piece right here works, right? Because it's slant. If I were right here, forget this piece right here for a second. If I were right here, just standing right here, as x decreases, y increases, just like this one. Again, you can put in the numbers if you don't believe me. My question to you is, does this piece of the graph work right here? I mean, if you look at it, as x decreases here, y stays the same. Watch. Let's put in some numbers. 0, 2, 4, 6, 8. I'll say this is 2, 4, 6. Now, I'm only concerned with this piece of the graph now. I've shown that this piece does fit the description, this piece here. But the whole graph has to work. So let's see if this piece works. Well, let's see. When x is 8, right? When x is 8, y is 2. When x is 6, I'm decreasing x. Y is 2. When x is 4, y is 2. So let's make a quick table so we can see this. When x is 8, y is 2. Decrease x. When x is 6, y is 2. Decrease x from 6 to 4. When x is 4, y is 2. So when x decreases or goes down here, y stays the same. Here it stays at 2. It doesn't go up or down. And that doesn't fit this description right here, if you read it. So this piece of the graph doesn't work. So I can get rid of 3. In short, after all that, the only graph that works is graph number 1. So let's get rid of D because it says graph 3 works as well. The only one that works is graph 1. Question 8. A company charges $8 an hour for lawn mowing. What would the company charge for a lawn that takes an hour and 45 minutes to mow? So I want to know the charge for 1 hour and 45 minutes. Well, so if it's 1 hour, it's $8. An hour and 45 minutes is more than an hour, so I know I'm going to make more than $8. So this is gone. E's gone. And A's gone as well, because if I mowed for 2 hours, 1 hour I would get $16, or 1 hour I'd get $8, and for 2 hours I would get $16. So this represents how much they would charge for 2 hours, but I'm only mowing for 1 hour and 45 minutes. So hopefully you can see I can get rid of 2 right off the bat, and if I need to guess, I have a better chance of guessing. So if you can do that in a question, go ahead and do that. It increases your chances of guessing the correct answer. But let's break this down here. It says every hour, I'm going to write down 1 hour. By the way, isn't 1 hour the same as 60 minutes? There's 60 minutes in an hour, right? So let me break it down this way. $60 minutes. How much money do I make? Well, it says every hour I make $8. There's 60 minutes in an hour, so this is the same as 1 hour. I make $8. Let's take half of this. What's half of 60 minutes? That's 30 minutes. What's half of 30 minutes? That's 15 minutes. You'll see why I'm doing this in a second. So, if in 60 minutes I make $8, if I work half that time, I'll make half of $8, which is $4. And now let's break it down this way. 30 minutes, this relationship here, I should say 15 minutes is half of 30 minutes. So in 30 minutes, if I make $4, if I work half that amount of time, I'll make half the amount of money. So this will be $2. Well, I can just add these up now, right? Because this is 1 hour right here. And then you should see here that these two add up to 45 minutes. So 1 hour is $8, right? That represents 1 hour. And 30 minutes plus 45 minutes, or 30 minutes plus 15 minutes is 45 minutes. So I just add these two to get the 45 minutes. 4 plus 2 is 6. Now I add these two together and I get $14. So my answer is B. Question 9. In a certain apartment building, apartments can come with 2, 3, or 4 bedrooms. They can have 1 or 2 bathrooms, and they can be located on the lower, middle, or upper level. How many different types of apartments are possible if any number of bedrooms, bathrooms, and locations can be combined? So are there 6 possibilities, 8 possibilities, 12? I'm going to show you the quick way to do this, and then I'm going to show you why it works. So first of all, let's look at the bedrooms right here. Let's just highlight this. The apartment can come in with 2 bedrooms, 3 bedrooms, or 4 bedrooms. So how many possibilities is that? Hopefully you can see that the bedrooms, there's 3 possibilities. I can have a 2-bedroom, a 3-bedroom, or a 4-bedroom. Now let's look at the bathrooms. We can have 1 or 2 bathrooms. So bathrooms, how many possibilities can we have with the bathrooms? Well, we could have an apartment with 1 bathroom or 2 bathrooms, so that's 2 possibilities. And let's see, let's look at the last piece of this. It says the apartment can be located on a lower, middle, or upper level. So the levels, there's 3 possibilities for the levels. It could be on the lower, the middle, or the upper. And then you just multiply these. Usually when I see that word combination, I think multiplication, not always. And let's just multiply it out. So 3 times 2 is 6. And then 6 times 3 is 18. And that's my answer right there. So 3 times 2 is 6 times 3 is 18. And that matches up with D. Now, you might be wondering, though, I mean, why are we multiplying? I mean, a lot of students will go ahead and add these up. And you will notice that if you add these instead of multiply, you get 3 plus 2 is 5, 5 plus 3 is 8. And that answer choice shows up here. And a lot of students will circle answer choice B. So I think it's important that you understand why we're multiplying. So I'm going to explain why, and it's going to take a little longer, but I think it's important to understand. So let me explain why. Let's make what's called a tree diagram, and I'll just make a little dot here. And let's start with the bedrooms. So we can have, if I branch it off, I can have a 2-bedroom, right? I can have a 3-bedroom apartment, or I can have a 4-bedroom apartment, right? 2, 3, or 4. 2-bedroom, 3-bedroom, 4-bedroom. Now, from the 2, 3, or 4 bedrooms, they can come with 1 or 2 bathrooms. So this 2-bedroom apartment can come with 1 or 2 bathrooms, right? Same with this. If it is a 3-bedroom apartment, it can come with 1 or 2 bathrooms. So the 3-bedroom can come with 1 or 2 bathrooms. And the 4-bedroom here can come with also 1 or 2 bathrooms. Now I'm going to continue to branch out. The 2-bedroom apartment can come with 1 or 2 bathrooms, and it can also be located on the lower, middle, or upper level. So it can be located on the lower, middle, or upper level. In other words, watch how I read this. I can have a 2-bedroom with 1 bathroom on the lower level. Or I could have a 2-bedroom with 1 bathroom on the middle level. And so on. That's how you read it. It's called a tree diagram. I can do the same thing here. I could have a 2-bedroom with 2 bathrooms located on the lower, middle, or upper level. Same thing here. I can just keep branching out. I can have a 3-bedroom apartment with 1 bathroom on the lower, middle, or upper. It's getting kind of ugly, my tree diagram, and I just keep going. I'm just going to continue to branch out lower, middle, upper, lower, middle, upper, lower, middle, upper. Let's keep going. Lower, middle, upper, lower, middle, upper, lower, middle, upper. Now, using our tree diagram, we can figure out the total possible combinations of apartments we could get. Let's just think this through. Let's go to the first branch. I could have a 2-bedroom with 1 bathroom on the lower level. So that'd be one possibility. And I can tally it out, right? Now, I could also have a 2-bedroom, right? 1 bathroom on the middle level. That'd be another one. Then I could have a 2-bedroom, 1 bathroom on the upper level. That's another one. And you just keep going. I could have a 2-bedroom, 2 bathroom on the lower level. That'd be another one. If you continue to tally these out, you'll keep counting them out and so on. You will see there's 18. And you can just keep following the branches. Or you could just count the end branches. Watch the end branches. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, which matches up with what we got originally. Question 10. A restaurant owner is planning to have a courtyard area sodded. The sod comes in rolls that are 3 feet long by 1 foot wide. If the courtyard measures 60 feet by 50 feet, which of the following expressions represents the number of rolls of sod needed? Now, sod it's just grass, right? I mean, you can just roll it out and water it and you'll have a nice green lawn. But let's draw a picture here, and first, again, look at your answer choice to see if there's any you can eliminate. I don't see any off the bat that we can eliminate at this point, so I'm just going to move forward and draw a picture. It said the sod comes in rolls that are 3 feet by 1 feet long right here, right? 3 feet by 1 feet long. So, I'm sorry, 3 feet long by 1 foot wide. So let's draw a picture of that. How about, I'll draw it like this. I'll put my 3 feet here and my 1 foot here. Now, you can draw in your units if you want to. You can put in feet and feet, but I'm going to leave it like this. Now it says if the courtyard measures 60 by 50 feet, that's my courtyard. I want to put in sods of grass. I should probably put this green because grass is green, but I'm not going to change it now. So this is 50 by 60. Now again, you can put the 60 here and the 50 here. It's okay if you switch this. The question is which of the following represents the number of rolls of sod needed? Which expression matches up with the number of rolls of sod needed? So basically, this is 3 right here. This is 3 square feet because 1 times 3 is 3. I'm just finding the area of this. So 1 times 3 is 3. And let's find the area of this, 50 times 60. Well, 50 times 60 is 3,000. So I got to put in 3 feet inside 3,000 square feet. We did a problem just like this previously. In other words, I mean, this isn't drawn to scale, but if I put this in, here one of these would be 3. Then another one would be 3. That would be 6. And then I'd have to put another 3. And I got to cover up 3,000 square feet. So I would go 3 plus 3 plus 3 and keep going until it totals up to 3,000. I don't want to do it that way. So basically what I'm figuring out is how many of these 3-foot pieces of sod can I put into this 3,000 square foot courtyard? Well, that involves division, right? So I'm just going to take this 3,000 and divide it by 3. You have a calculator you can use, but let's see, 3 goes into 3 once. It's just gonna be 1,000. And that's going to be my answer right here. And you can use your calculator. I just went 3,000 divided by 3 is 1,000. So in other words, I can put in 1,000 of these, and I guarantee you if you kept going, right? If you kept going and put in 1,000 3s, 1,000 of these, I mean, obviously this isn't drawn to scale, and you added them all up, it would be 3,000. So I can put 1,000 of these rolls of sod inside this courtyard. So I got to figure out which one of these gives me my target answer right here of 1,000. Well, A's gone, right? 60 times 50 is not 1,000. This has got to equal 1,000, so that's gone. Let's see, 60 times 50 divided by 3. I think this is going to work. Well, maybe not. Let's keep it. Let's just punch this into the calculator and see if we get 1,000. Let me just punch it in. So I'm punching in this b. So I'm going to go 60 times 50 divided by 3. And that, yeah, that is 1,000. So when I punch this piece into the calculator, this gives me 1,000 right here, which matches up with this. And that's my answer. And I move on. Question 11. Consider the equation 6x plus 7 equals 3x minus 5. Which of the following possible first steps would prevent having to deal with fractions when solving the equation? So let's write this equation over here. 6x plus 7 equals 3x minus 5. Now, you don't even really need to know how to solve an equation to approach this problem. What it's asking is if I were to combine the 3x and the 6x as my first step, would I get a fraction? No, you wouldn't. It's impossible because there's only two possible ways to combine 6x and 3x. Right? You could go 6x plus 3x, or you could go 6x minus 3x. Now, if you were solving this equation and you know how to solve equations, you would have to go 6x minus 3x. But we don't really need to solve this equation. So if we were to combine these, combining means to add or subtract like terms. So it's one way to look at it. 6x plus 3x is 9x, and 6x minus 3x is 3x. Are there any fractions when we combine these two terms? No, there's no fractions. So I know that one, now careful there, it says which of the following possible first steps would prevent having to deal with fractions. So if I do step 1, it prevents me from dealing with fractions. So step 1 has to be part of my answer choice. So let's see, not step 1, but Roman numeral 1, I should say. So let's see. What can I eliminate? Again, Roman numeral 1 has to be part of my answer choice because when I combine these two, I do not get a fraction. So I can get rid of B, C, and that's it. Because B and C do not contain Roman numeral 1. A, D, and E do. Okay, now let's see if I combine the 7 and 5, would I get a fraction? Well, let's see. If I combine the 7 and the 5 here, well, when you combine, you can either add them or subtract them. So if I add 7 and 5, I get 12. If I subtract 5 from 7, or go 7 minus 5, I get 2. These are not fractions, they're whole numbers. So when I combine the 7 and the 5, I don't get a fraction. It prevents me from having fractions. So I know that Roman numeral 2 has to be part of my answer choice. So anything that doesn't have a Roman numeral 2, I get rid of. This doesn't. And these two do. So now I have a 50-50 chance of guessing. Now let's look at the last step. Dividing both sides of the equation by 6. Now I'm going to have to use the actual equation. And it's telling us to divide both sides of the equation by 6. So this is my left side, this is my right side. If I divide both sides of it, basically what I'm going to do is divide this side by 6. And I'll divide this side by 6. And look, I'm going to get a fraction right here. Because watch how I break this up. You can rewrite this as 6x over 6 plus 7 over 6. It's the distributive property. What I did is just said 6x divided by 6 and 7 divided by 6. I just separated the 6 out. These really mean the same thing. And right here I got a fraction. 7 divided by 6 will not give me a whole number. So when I divide both sides of the equation by 6, it does not prevent me from having fractions. So step 3 does not work. So anything that has a step 3 in it, I get rid of. this one. And let's see, we're left with A and D now. So which one is going to be my answer? Well, 1 and 2 both worked. So 1 or 2 only worked, right? We already established that when I combine these, I didn't get a fraction. When I combine these, I didn't get a fraction. So 1 and 2 both work, so I can eliminate A because that only contains Roman numeral 1. So my answer has to be D. Little confusing. These are confusing when you have them like this, but hope that made sense. Let's go to the next one. It states, number 12, a book states that the longest river in a country is about 3,700 kilometers. The actual length of the river is most likely between which one of these numbers? So I'm going to highlight my final question. It says the actual length is most likely between. What does that mean, between? What if I said to pick a number between 1 and 100? I said, you have 1 and you have 100. Pick a number between 1 and 100. Well, there's a whole bunch of numbers between 1 and 100. You could pick a 2. You could pick an 88. Both of these numbers are between 1 and 100, right? You wouldn't pick 1 and you wouldn't pick 100. So the question is asking, 3,700 would have to be between which two of these numbers, A, B, C, D, or E? I can see some that I can eliminate right off the bat. Remember, between, think of when someone says, what's between 1 and 100? Think that in your mind. With that in mind, what do you think we can get rid of? Well, let's see. If I said, let's look at A, pick a number between 3,600 and 3,700, right, from here, it couldn't include this number. 3,700 can't be between itself. Again, think of 1 and 100. If I said pick a number between 1 and 100, you wouldn't use 1 and you wouldn't use 100. You'd pick numbers between it. Same concept here. If I said pick a number between 3,600 and 3,700, it could not include this number or this number. So 3,700 can't be between 3,600 and 3,700. It doesn't make sense. So A's gone. What else can I get rid of? Using the same thinking, B has to be gone. Using the same thinking, D has to be gone. Using the same thinking, E has to be gone. The only possible choice is C. It's the only possible choice, right? So in other words, if I said pick a number between between 3650 and 3750, 3700 is between these two. Hopefully you can see that D and E doesn't work, right? If I said pick a number between 3,700 and 3,800, it wouldn't make sense to pick 3,700. So C is my answer, and I move on. Question 13. Which of the following correctly expresses X decimeters, Y centimeters, and Z millimeters in terms of meters? Well, this is something you need to kind of know. You need to know that a decimeter is 1/10 of a meter. So for example, if I had a meter stick and I broke it up into 10 pieces, like so, 10 evenly spaced pieces, and let's say this is 1 meter. A decimeter is 1/10 of that. It's 1/10 of this whole thing. So this distance from here to here, would be 1 decimeter, assuming this whole thing from all the way here to here is a meter. So this would again be 1 decimeter. So a decimeter is 1/10 of a meter. Centimeters are 1/100th of a meter, and millimeters are 1/1000th of a meter. So again, for example, if I had a meter stick, and you can get a meter stick, and I broke it up into 100 different pieces, 100 of these, 100, this distance would be 1 centimeter. So based on that, hopefully you can find the answer. Let's see. X goes with decimeters. So the X piece, there has to be a 10 attached to it somehow, probably a 1/10. The Y needs to have 100 with it, and the Z needs to have 1,000 with it. So let's say you didn't know anything about this problem. You could use the process of elimination if you know what the prefixes deci, centi, and milli mean. So let's go ahead and start eliminating stuff. I know the X has to have a 10 with it some way. So here, let's see, X has a 10 with it. Here, X doesn't have a 10 with it. Here, X does have a 10 with it. Here, X doesn't. Here, X does. So these are all gone. Anything where the X doesn't have a 10 with it associated with it somehow. So this is gone. This is gone. And now I need to keep the rest. Now I could look at the Y's. The Y has to have 100 attached to it somehow. Right? So here the Y has 100 attached to it. Keep it. Here the Y has 100 attached to it. But we already get rid of this, so don't even worry about B and D. Let me cross it out this way. We don't need to look at those anymore, so it doesn't confuse us. Here the Y has 100 attached to it, and here the Y doesn't. So this one's gone because the Y has a 10 attached to it. So this is gone, and now I'm down to A and C. And while you're doing this, you can guess if you're running out of time. It increases your chances of guessing. So which one do you think it's going to be? Is it going to be A or C? Here the X has a 10 with it. So does it here. And the Y has 100 with it. So does it here. Z has 1,000 with it. So does it here. Well, it's going to be A because I already explained that we're using division here. We're using fractions here. So the answer will be A. Let's move on. 14. It says a group of hospital workers belonging to a union each earn the same hourly wage. The union dues are 2% each day, or each paycheck, regardless of whether the employee works full-time, half-time, or quarter-time. Does this mean that the amount of money deducted will be the same for all employees? Careful here. It's kind of tricky. I'm going to highlight the final question. Right here. Does this mean that the amount of money deducted will be the same for all of the employees? Now, most people initially say yes because they see that every paycheck has 2% taken out of it, regardless of whether the employee works full, half, or quarter time. So they think, yes, they all have 2% taken out of it. So the rate, the 2% rate is the same, but that's not what they're asking. They're asking, is the amount of money deducted the same? Not if the rate of 2% is the same. So careful there. It's not going to be yes. I can tell you that right away. And you'll see why in a second. So I want to eliminate A. And then we have 4 more answer choices. So let's say, for example, we have a full-time employee. Now they all get paid the same hourly rate, but the full-time person's going to make more money because they work longer. So we have a full-time, a half-time, full-time, half-time, and a quarter-time. So let's just make up some numbers. Let's make up a paycheck for the full-time employee. Let's say he makes $1,000. So I'll put the full-time employee makes $1,000. And the half-time employee would make $500. And the quarter-time employee would make $250. Now, if you mess up these numbers, that's okay. What you really need to do when you're making up numbers for this particular problem is just make sure that the full-time employee has the highest salary, and then the half-time employee has some number less than 1,000, and the quarter-time employee has something less than 500. Let me explain. I did this exactly like the problem was worded. But let's say you had the full-time employee. Let's say you made up a different number like $10,000. You can put really whatever you want for the half-time employee, just so long as it's less than this number. And you can really put anything you want for the quarter-time employee, just so long as it's less than this number. So in short, the full-time employee makes the most amount of money. The half-time employee makes the next amount, and the quarter-time employee makes the least. I mean, based on that, you should be able to figure out what the answer is, hopefully, but I'm going to continue just to make sure you understand what's going on. If you see the answer at this point, move on. Now, it says the union dues are 2%. That means that each person has 2% of their salary taken out. 2% of the salary. When I say that word of, it implies multiplication. So it's going to be 2% times the salary. So I'll go 2% here. I'm taking the salary that I made up, right? These numbers are just made up, times 2%. This person also has 2% taken out. And this person also has 2% taken out. These are taken out for their union dues. Well, remember, we can rewrite this piece here, because I'm going to do this on the calculator, as 1,000 times 2 out of 100, right? Hope you can see that. Remember, percent means out of 100. So again, let me make sure you can see that. In other words, I'm just rewriting this as 1,000 times 2%. Percent means out of 100. And I went over that in a previous problem. So let's just punch that into the calc, see what we get. So 1,000 times 2%, or 2 divided by 100, 2 divided by 100. Well, this is going to equal 20. So in other words, the full-time employee had $20 taken out of his paycheck. If I go through the same process here, if I take 2% of 500, and you can punch that into the calculator, I'm going to get $10. And for this one, I will get $5. You can punch those into the calculator. So you should see that the full-time employee has the most amount of money taken out, right? And let's go through each answer choice so you're clear. Let's see. So let's go back to the original question. Does this mean that the amount of money deducted will be the same for all employees? No. And then C says, well, no, let's go to B first. It says no. the quarter-time employee will have the greatest amount deducted. No, that's wrong. The quarter-time employee has the least amount deducted, so that's gone. What about C? No, the half-time employee will have the greatest amount deducted. No, the half-time employee doesn't have the greatest amount deducted. The full-time employee does. That's gone. Let's look at D. No, the quarter-time and half-time employees will have the greatest amount deducted from their paychecks. No. That is not true, because the quarter-time and the half-time employees, as we already said, don't have the greatest amount deducted from their paycheck. The full-time employee does. The answer has to be E. It says no. The full-time employee will have the greatest amount deducted from their paychecks. You can see that the full-time employee has the greatest amount deducted. $20 is higher than $10 or $5. So E is my answer. Now, I went through a lot here. You might have been able to see this quickly. I wouldn't even recommend that you go through this. If you see this and you see the answer is E, boom, move on. The reason I'm taking more time is I'm trying to get you to understand the concepts of what is going on. But when you're actually taking the test, you use the process of elimination and try to eliminate incorrect answers and narrow it down. And if you have to guess, increase your chance of guessing. You don't want to spend too much time on one problem. You need to balance your time. Let's move on. Question 15. An auditorium has a seating capacity of 1,500. For an upcoming community theater play, tickets cost $4 for adults. I'm going to highlight that little piece. It's $4 for adults. And for children, it's $2. At last year's play, twice as many children attended as adults. So twice as many children attended as adults. If the attendance at this year's play has the same ratio, that just means that for this year's play, there's going to still be twice as many children as adults. That's what it means by the same ratio. Which of the following expression represents the best estimate of the total amount of money from ticket sales when the auditorium is filled to capacity? Well, you can go ahead and do fancy algebra and set up equations to do this. Honestly, for standardized tests like this, if you can get around using the algebra, I would prefer that you do it that way because it goes quicker. And in a problem like this, I'm going to use my answer choices to help me. So let me do a little teaching first. You should see that it's $4 for adults. That just means that we're going to have $4 times the number of adults that attend. And the children is $2. It's $2 for the children. So I'm going to take $2 times the number of children that attend. This will represent my cost. Or it's not my cost, but the total amount of ticket sales. So for example, if I had 100 adults, let's say, show up, right? Let's say I'm just making these numbers up. I would take $4 times 100 to get the ticket sales. Well, let's say 100 adults showed up. How many children would have to show up? Well, it says right here it's twice as many children. So if there were 100 adults, there'd have to be 200 children. And the cost here for the children would be $2 times 200, which is $400. So that's just a little teaching on the side, but there's something I want you to see here. Wherever I see $4 in my answer choices, it represents the cost for the adults, like right here. So I know this $4 represents the cost for the adults, and this is the number of adults. I'll say A represents adults. I'm not going to write that there. Wherever I see a $2 in my answer choice, it represents the cost for a child. So here, this is $2 for the number of children. So watch. This is what answer choice is saying. There was 1,500 seats at the auditorium. It's saying all adults came. They filled up the 1,500 seats. So there were 1,500 adults that showed up, and they all paid $4. But there were no children here. There's no children added onto this. This just means only adults showed, and only adults showed up. And we can make the assumption from the problem that adults and children were both present. So this just says only adults showed up. So I am just going to get rid of this one. It doesn't make sense. This one says only children showed up. 1,500 children showed up, and it was a cost of $2. Again, I know this is the children because it says $2. It says $2 for children. I know this is the adults because it says $4. $4 for adults. So B has to be gone as well, because this implies only children showed up. Now, let's go to C and see if it makes sense. This means, remember when I see the $4, we're talking about the adults. This means that 750 adults showed up, and they paid $4, plus 750 children showed up, and they paid $2. Again, I know this is children because of the $2. Do you think C is the right answer based on this example I showed you? Hopefully you can see that it's not, because in this situation, the number of adults and the number of children are the same. It was 750 adults, 750 children. If you add that up, you get a total of 1,500 people that attended, and that's the maximum capacity. But it says here, twice as many children attended as adults. So C is gone. Let's look at D. This says 1,000 adults showed up. They each paid $4. And this means that 500 children showed up, and they each paid $2. And again, if you add 1,000 plus 500, you'll get the total capacity of 1,500. So do you think this is the correct answer? Again, it said twice as many children attended as adults. Look over here for this little sample problem. Well, that means that more children showed up than adults, because twice as many children showed up. This says there were more adults than children. Right here. This is saying there's more adults than children. I want to get my red pen. This is saying 1,000 adults showed up, they all paid $4, and 500 children showed up, they paid $2. But we know that there were more children than adults, because it says twice as many children attended as adults. So it can't be this one. This is actually backwards. This is saying that twice as many adults attended than children. So this is gone. The only one that's left is E, and that's my answer. I'll go over why it's correct. If I were taking the test, I would just move on. But this is telling us that, again, 500 adults showed up, $4 a piece. This is telling us 1,000 children showed up for $2 a piece. It all works out here. The number of children is 1,000. The number of adults is 500. So the number of children is twice the number of adults. And the adults paid $4. The children paid $2. And the total capacity, well, 500 adults plus 1,000 children totals to 1,500, which is the maximum capacity. Let's move on. Question 16. If a bathroom door is 2 units tall, 1 unit most likely represents a meter, kilometer, centimeter, decimeter, or millimeter. It's basically asking this. If you were to measure a bathroom wall, would you say, not a bathroom wall, a bathroom door, would you say the door is, would it make most sense in the real world to say the door is 2 meters tall, 2 kilometers tall, 2 centimeters tall, 2 decimeters, or 2 millimeters? I just recommend going on Google and searching up a meter stick if you don't have one. If you have a meter stick and you put it next to a door it would be measured in meters. This would be 1 meter, meter stick. If this were drawn a scale, it would be about like this, and this would be another meter. So this is just something you kind of need to know. It only makes sense to say that a bathroom door, how tall is it? It would be about 2 meters. That would make sense. And it's just, this is even hard to explain. I recommend Googling a meter stick again and seeing the length of it so you get an intuitive feel of what 1 meter is. So the answer here is going to be A. Question 17. After completing her 4-year college degree, Lynn has a $20,000 loan. She earns the average monthly income for her level of education. If her living expenses are $1,700 per month, then how many months could Lynn pay off her loan? This is a great time to highlight or underline that final question. If her living expenses are $1,700 per month, then how many months could Lynn pay off her loan? In other words, would it take her 25 months to pay off her loan? Would it take 20 months to pay off her loan? Would it take 15 months, 12 months, or 8 months? It's so important in problems like these to highlight that final question so you know what your answer choices represents. It represents the months to pay off her loan. Now it says she earns the average monthly income for her level of education, and she has a 4-year college degree. So we're going to need to go to the table, level of education, 4-year college degree. Her average monthly income is $2,700. So every month she makes $2,700 from here, right? What are her expenses? It says, let's see, her living expenses are $1,700. So we're going to have to subtract $1,700 from the amount of money she makes. So $2,700 minus $1,700 leaves her with $1,000. And she can use this $1,000 to pay off her loan. Well, her loan is $20,000. She can use $1,000 to pay this off. So she can use this $1,000 left over to pay off her loan. How many months would it take her? In other words, what I'm asking is, how many thousands come out of 20,000? I'm thinking division. It's one way to do it. Let's say it took her 25 months. Let's use our answer choices. If it takes her 25 months and she's paying $1,000 off a month, what's 25 times 1,000? Does that equal 20,000? No, that equals 25,000. So this is gone. Let's look at B. If it takes her 20 months to pay off her loan, and she's paying it off at a rate of $1,000 per month, that would be 20,000 times 1,000, which equals 20,000. So in other words, it's going to take her 20 months to pay off her loan. So your answer is B right here. Again, I like to summarize when I'm done. She has $1,000 left over after her expenses to pay off her loan of $20,000. It will take her 20 months. Another way to look at it is 1,000 times 20 months equals $20,000, and that's how much she needs to pay off. So it will take her 20 months. Let's move on to the next question. Again, and I should have stated this in the previous problem, it said questions 17 and 18 refer to the same table. So I have the same table again, and we're going to use this same table to answer a different type of question. It says, on average, approximately how much more money will a person who has a 2-year college degree earn in an entire year compared with a person who has a vocational degree? So on the table, we're going to go to a 2-year college degree and a vocational degree. And let's see. Let's read this. In an entire year, right here. We're comparing an entire year worth of salary. So this is measured in months here. So how many months are in 1 year? Hopefully you know that 1 year contains 12 months, right? 12 months. So the vocational person earns this much every month. How much would they earn in a year? Just multiply this times 12. And the 2-year college degree earns this much every month. Just multiply that by 12. And let's do that. So 1750 times 12 equals 21,000 for this person. Per year. And this person's 2,000 times 12. And that's 24,000. And the question asks, let's see, on average, approximately how much more money will the person who has a 2-year degree earn in an entire year compared to a person with a vocational degree? So this 2-year degree person right here, how much more money did they earn over a year period? In other words, 24,000 is how much more than 21,000? Hopefully you can see that's $3,000. And C is my answer. Now before moving on, I noticed there is a trap answer here. The trap answer is one that they want you to circle right off the bat, is this one right here. Let me show you why real quick. A lot of students, when they don't read the full question. Let me actually just clear everything out. Again, the answer was C. Just going to go back. So they look at the question. By the way, let me just recircle C. I want to show you why A is a trap answer. On average, approximately how much more money will the person from the 2-year college earn compared to the person in the vocational? So they go to the 2-year college, they go to the vocational, and they immediately they subtract them, right? They say, oh, well, how much more is 2,000 than 1750? They subtract these two, put 250, and circle A. That's a trap answer because you're not reading your question. You have to be careful here. It says this is the average monthly salary. It says a person who has a 2-year degree, let me reread this. On average, approximately how much more money will a person who has a 2-year degree earn in an entire year? And this is measured in months. That's why you had to go through the process of multiplying these by 12. So if you're going too quick, you're going to circle A. Just wanted to point that out. Question 19. The city water department reported that the average amount of water used per household each month in the last year was 1,000 cubic feet. Employees from the department randomly sampled 50 homes in the community and reviewed the water bills for a recent month. Which of the following would most likely be true of the water consumption of 50 households? So which one is most likely true? Not 100% true, but most likely true. So let's kind of just think of this in terms of the real world. There's 50 homes. 50 homes, right? Think of your own neighborhood, right? And there's 50 homes in that neighborhood, and the city department randomly samples these 50 homes to see how much water is used. Do you think everybody in your community is going to use the exact same amount of water? Do you think all 50 homes are going to use 1,000 cubic feet of water? So that would be like this. The first home, you sample it exactly 1,000 cubic feet. The second home, you sample it exactly 1,000 cubic feet. That does not make sense to me. When they randomly sample stuff, you're probably going to have a certain amount of people who are going to use a little less than 1,000 and a certain amount a little more than 1,000. You might have one or two homes that use exactly 1,000, but this is most likely to be true. So in other words, when they go out and sample these homes, the first home might use maybe 989 cubic feet. And the second home might use 1,002 cubic feet of water. And the third home might use 1,005 cubic feet of water. It's not likely that you'll have many that are exactly 1,000 cubic feet. The average of the 50 homes will be 1,000 cubic feet. So based on that, let's see if we can figure out the answer to this. Let's see. A, each household will use exactly 1,000 cubic feet? No. Again, that's saying that every household that they sample in your community, they all use the same amount of water. That does not make sense. See you later, A. What about B? Now, B says each household will have used at least 1,000 cubic feet of water. It's a little trickier. At least 1,000 cubic feet. That means, this word at least especially is confusing. At least means you're going to use 1,000 cubic feet or more. Think about it. If I said you have at least $100 in your wallet, you would have $100 or more. So, what this is telling us, B, is that of the 50 homes, some will use, the majority will use over 1,000 cubic feet. I might have one that uses 1,100 cubic feet, and maybe another one that uses 1,101 cubic feet. I mean, they'll be close to 1,000, but not exactly. And maybe one that uses 1,001 cubic feet. Maybe one uses exactly 1,000 cubic feet, but none of them can go under 1,000. Might have one that uses 1,200. The point is, this is not going to make sense, because if I were to average these, it wouldn't be 1,000 cubic feet. It would be higher than that. More than likely higher than that, because I'm probably going to have some homes that use under 1,000 cubic feet, so this is gone. C. Each household will have used at most. Now, at most means 1,000 feet or less. Think about it. If I said you have in your wallet at most $100, you would have $100 or something less than that. So this is telling us here in this one, done with this one, that the homes use, for the most part, less than 1,000 cubic feet of water. Maybe someone uses 950 and another one uses 900 and another one uses 800. Another one uses 999. Maybe one uses exactly 1,000. But it can't go over 1,000 cubic feet. If I were to average these out, it would be less than 1,000 cubic feet. Remember, it says the city water department reported that the average amount of water used in the household each month last year was an average of 1,000. If I use these numbers, the average will be less than 1,000 because an average measures, it is like a good representation of the numbers given, and this would be an average of less than 1,000. So as a result, C is gone. Let's look at D. "25 of the households will have used more than 1,000 cubic feet, and 25 of the households will use less than 1,000 cubic feet." This makes the most sense to me because it says which of the following would most likely occur. So this is saying you have some above 1,000, right? 1,000 is the average. You have some above 1,000 and some below 1,000. If you average it out, you'll get 1,000. So you might have some using like 1,200 and another one using 1,100 cubic feet of water. And here you have maybe someone using 900 and someone here using 950. And if you get a good average of these, it'll average about 1,000. So D makes the most sense to me, and I would circle that. Let's just look at E, see why it doesn't make sense. It says 25 of the households will have used exactly 1,000 cubic feet. Remember, when you're doing these types of problems, don't use your common sense, right? If they were sampling 50 homes in your neighborhood or in your community, 50 homes, everyone's for the most part going to be using slightly different amounts of water. It would be very rare to have 25 people using the exact same amount of water. That just wouldn't make sense. When you go out into the real world, everyone's using a little bit different amount of water, and that's why E is gone. Let's move on. Question number 20. A family has decided to plant a rectangular garden along the entire length of a 25-foot long fence in the backyard. If the family wants to have a plot of 125 square feet within which to plant, how many feet wide should the garden be? Let's highlight the final question. How many feet wide should the garden be? So now I know my answer choices represent the width of the garden. Should the garden be 5 feet wide, 25 feet wide, 50 feet wide, 75 feet wide, or 100 feet wide? You could even write off to the side width of garden so you don't forget. Width of garden. So you know exactly what your answer choices represent. Now, it says a family has decided to plant a rectangular garden, right? Rectangular garden along the entire length of a 25-foot long fence. 25-foot long fence. So let's draw a 25-foot long fence. I'll label this as 25 feet. This is my fence. And they're going to have a rectangular garden, like so. And your goal is to find the width of the garden, this length right here. You don't know it. This is a question mark. Now, you got to think about what it is that you're looking for. Are you trying to figure out the perimeter of the garden or the area of the garden? The perimeter is the distance around the rectangle. The area is the stuff inside. Well, you have a clue word right here. If you look at this, it says the family wants to have a plot of 125 square feet within which to plant, right? So they're going to be putting plants inside of here, right? It's an awful picture. But we're putting the plants on the inside of the garden. We're not going to put plants along the border of the garden because it says within which to plant. So that's going to help us realize that we're dealing within the garden, or the space inside the garden, which represents area. Now I know I'm dealing with area, and you'll have a formula sheet, I believe, for some basic formulas, but the area of a rectangle is the length times the width. And they give us the area right here. It's 125 square feet. And this word square feet, when you see the word square feet, it implies area. If it just said 125 feet without the square, it would imply perimeter. So that's another clue word. This square feet tells us that this 125 represents the area. So the area equals 125 square feet. So now we're getting somewhere. This is my length, this is my width. So 25 times what number, when I multiply it with the width, gives me 125? Well, let's just look at our answer choices to help us. You know what? I can eliminate all of these, and I can see the answers A, because let's think about this. The length is 25. If the width were 25, 25 times 25 is way bigger than 125, and same with these numbers as well. So my answer is A. Let's check it. Let's put the width in, the width of the garden to be at 5. And I'm going to take 25, the length, times 5, the width. And when I multiply these two, I'll get the area of 125. times 5 equals 125, and that matches up with answer choice A. So my width has to be 5 right here. So I circle A. And I'm done. Question 21. The efficiency of converting from one form of power to another form is defined by the formula efficiency equals output power divided by input power. If the efficiency remains constant, which of the following is true? So I want to know which one of these statements are true. Now this word constant says the efficiency remains constant. Constant means it doesn't change. It stays the same. So what I'm going to do in this problem is just make up some numbers. Let's bring this over here. And when I'm making up numbers, I like to use small numbers. I try to stay away from 1 and 0. So let's use 2 in this problem. Let's say the efficiency here is 2. And it says the efficiency remains constant right here. That means it's always going to be 2. It's not going to change. Now it says the efficiency equals output power divided by input power. So what I'm going to do is create some ratios. This is a ratio. When you use division, this ratio will always equal 2. So let's think of some ratios that equal 2. I'll help you out at the beginning. How about 100 divided by 50? What's 100 divided by 50? That's 2. So remember, the top number is your output power. So in this situation, the output power is 100 because 100 is our top number, right? And the input power is on the bottom. So our input number is 50. So when the output power is 100 and the input power is 50, this ratio gives us 2. Can you think of another ratio that gives us 2? Well, let's say our output power is 20. So I'll put the 20 on the top. On the bottom, I'll put the input power is 10. Does this ratio give us 2? Yes. And remember that it has to always be 2 because the efficiency is constant, and constant means it doesn't change. So come up with another ratio that's 2. It doesn't have to be the same as mine. It can be. How about 2 divided by 1? Let's use that one. This ratio gives us 2 as well. 2 divided by 1 is 2. So if the output power is 2 and the input power on the bottom is 1, this ratio gives us 2. Let's come up with one more. How about Let's see, how about 24 divided by 12? That works as well. So we have a whole bunch of ratios that give us a constant efficiency. Now, let's go over to our question here. You should notice that it always says when the input power, right? When the input power. It's always asking about the input power at the beginning, right? So this is when the input power remains constant, when the input power increases, when the input power decreases. So I want to look at my input powers first here, which is the number on the bottom. It's the 50, the 10, the 1, and the 12. I want to look at those first because when I read my answer choices, it starts with the input power. So let's do that. What I'm going to do is order my input powers from smallest to largest. So what is the smallest input power? So remember, the input powers are on the bottom, right? So we have an input power here of 50, 10, 1, and 12. I want to order them from smallest to largest. So the smallest input power here is a 1. So I'm going to write this ratio first, this one here. I'll write it. I'm going to just order these. And remember, I'm ordering from the smallest input power to the biggest input power. So the smallest input power was 1, so I wrote 2 over 1 first. What's the next smallest input power? We have 10, 12, and 50. Well, the next smallest is 10, right? So I'm going to write this ratio next. This one's gone. I'm going to write this ratio next. So 20 over 10. What's the next smallest input power, 50 or 12? Well, it's 12. So I'm going to write this ratio next, 24 over 12. And the largest input power is 50. So I'm going to write 100 over 50 next. So I just ordered these from smallest to largest with my input power. So let's look at our input powers now. They go from 1, 10, 12, 50. They go from smaller to larger. They're increasing. The input powers are increasing because that's how I ordered them. Now I need to figure out what's happening to the output powers, the number on top. So let's see what's happening to the output powers. That's the second thing we're looking at. It goes from 2 to 20 to 24 to 100. So you should see when I order the input powers from smallest to largest, so in other words, when the input powers are increasing, what do you notice about the output powers? They're increasing as well. So which statement says that? Which statement says when the input power increases, the output power increases? Why don't you look at them and see if you can pick the correct answer? Well, it looks to me like E. E says when the input power increases, boom, 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 right? The output power increases. Boom, boom, boom. So E is my answer. Now, if D confuses you, what this means is when the input power goes down, the output power stays the same. So that's why D is gone. You don't need to go through each one of these. This one says when the output power goes down, when the input power goes down, the output power increases. You can read through each one of them, and you'll see it doesn't match up with this. So in short, my answer is E. Question 22. At a track meet, the officials measure the long jumps to the nearest 1/100th of a meter. If a participant's jump is recorded at 6.50 meters, the actual jump is probably between which one of these numbers? Now we did a problem similar to this. So in other words, the actual jump is somewhere between which one of these? Another way to look at this is, and again, we did something similar to this. They're basically asking the following. 6.50 is between which one of these numbers? Is 6.50 between 6.45 and 6.50? Is 6.50 between 6.495 and 6.50? And so on. Now they said up here the jump was measured to the nearest 100th of a meter. You really don't need this information in the problem, so I'll just cross that out. So again, let me go over the concept of what between means. If I said pick a number between 1 and 100, There's a whole bunch of numbers between 1 and 100. 2 is between 1 and 100. 10 is between 1 and 100. 50 is between 1 and 100. This is a special number. It's the number right smack dab in the middle. 99 is between 1 and 100, right? So again, if I were to say pick a number between 1 and 100, you might pick 2, you might pick 50, you might pick 99, but you would not pick 1 and you would not pick 100. It would not make sense. If I said pick a number between 1 and 100, again, you wouldn't say 1. Hopefully that makes sense to you because we're going to use that thinking to do this problem. So based on that and based on a problem we did earlier in the video, and you might have not watched this whole video, it's kind of long, what do you think the answer is? Why don't you pause the video and see if you can figure it out? Welcome back. Well, let's look at A real quick. Let's look at A. We have 6.45 and 6.50. Right? Let's pretend this is money. And I'll put a dollar sign here too, even though it's really not money. If I said pick a dollar amount between $6.45 and $6.50, you would probably say, oh, how about $6.46? Or you might say $6.49, right? You wouldn't say $6.50. So it doesn't make sense that $6.50 is between $6.45 and $6.50. Right? It would be numbers between, like $6.46, $6.47, $6.48, or $6.49. So A is gone. You can use the same reasoning to get rid of B, D, and E. And your answer has to be C. And I'll show you why in a sec. Let's just go over one more to make sure you got this, because it's tricky and you could see one like this on the test. Let's look at this one. Let's look at D and see exactly why D doesn't work. We have 6.50 and 6.505. Well, it's really the same reasoning, right? I mean, if I said pick a number between 6.50 and 6.505, it would not make sense to pick this number because it's the same as this number. So it's pretty much the same reasoning, a little bit trickier. Let's go over why C is the correct answer, so you clearly see it. This is 6.495. Right here. And this is 6.505. Now again, let's pretend this is money, the 6.50. Put a dollar sign here. If I add an extra zero here, it doesn't change the amount. That's still $6.50. It wouldn't make sense to include a zero here because we don't have a coin this small. But you need to see that this amount and this amount would both represent $6.50. So again, I'm just going to tack on a zero here. It doesn't change anything. And now you should see that this is between these two numbers, right? In other words, 6.500, which is the same thing as 6.50, is somewhere between this number and this number. I hope you can visually see that now. And if you can't, I just noticed something here. Let's drop off the units here. Pretend that 6 isn't there. You should see that 500 is somewhere between 495 and 505. So that is why C is my answer. Question 23. Consider the table below. 1,000 bytes is approximately 1 kilobyte. 1,000 kilobytes is approximately 1 megabyte. 1,000 megabytes is approximately 1 gigabyte. And these little squiggly lines mean about. It's not exact. Using the approximations in the table, which of the following expressions represents the number of bytes in 2.4 gigabytes? Let's go to our answer choices and see if there's anything we can eliminate. I really don't see anything off the bat that I can eliminate here, but I do notice something. I notice that 2.4 is in every answer choice. That means my answer is going to contain a 2.4. There's a 2.4 over here, so I'm not going to worry about that piece in the problem. I'm just going to cross this 2.4 out here, 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 and all the way down. That's because it's contained in every answer choice. Now, what this question really boils down to is the following. It's asking for the number of bytes in a gigabyte. How many bytes are in a gigabyte? So let me show you how I go about this. And again, I can get rid of that 2.4 because it's in every answer choice. If there was one answer choice that didn't have the 2.4, then I couldn't drop this off. So the first thing I'm going to do is look at this piece right here, where it says 1,000 kilobytes is approximately 1 megabyte. I'm going to rewrite this as 1,000 times 1 kilobyte equals 1 megabyte. I didn't really change anything. Instead of writing this as just a kilobyte, I said times 1 kilobyte. It's the same thing. Watch, if I multiply this out, if I go 1,000 times 1, that's 1,000. Then I just bring down my kilobytes. So this is the exact same as this. And you're going to see why I did that. It's going to make the substitution easier. So what I'm going to do now, I'm going to look up here now, and it says 1 kilobyte equals about 1,000 bytes. So I'm going to replace this 1 kilobyte here, right here. I'll put parentheses around it just to make it easier to see. I'll replace it with 1,000 bytes right here. Again, I can do that because it says 1 kilobyte equals 1,000 bytes. So I'm replacing this 1 kilobyte with this. So watch how I do that. 1,000 times, replace this with 1,000 bytes from right here. Make sure you write this word bytes in there. That's going to equal 1 megabyte. Now, let's multiply 1,000 times 1,000. Well, that's just going to be a total of 6 zeros, right? When you multiply by base 10 numbers, you just look at the zero. So this will have 6 zeros now. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So this becomes a million. So 1,000 times 1,000 is a million. Bring down your bytes. Equals 1 megabyte. So now I know that a million bytes is equal to 1 megabyte. But I want to know how many bytes are in a gigabyte. So let me go ahead. I'm going to actually rewrite this thing here up on the top. Let me just recopy it up here. You'll see why in a second. So we have the conversion 1 million bytes equals 1 megabyte. So I just rewrote this up here. Let me erase this. And what I'm going to do is the following. I'm now going to go to this piece right here. Right here. Right, I'm just going to give myself a little more room. And I'm going to rewrite this as 1,000 times 1 megabyte. Same reasoning that I did before. So 1,000 times 1 megabyte. Right? I just rewrote this 1,000 megabytes as 1,000 times 1 megabytes. Doesn't change anything, and that equals, I should put approximately. Don't worry, if I put an equal sign, it's all good. These little squiggly signs mean approximately. It's not going to throw off anything. And that's going to equal, let's say I was down here, that's going to equal 1 gigabyte. So I just rewrote this piece like this. Now it says here that 1,000 bytes equals 1 megabyte. So I'm going to replace this 1 megabyte with, I meant to say 1 million bytes equals 1 megabyte. I'm going to replace this 1 megabyte here with this. See that? So let's rewrite this. It's going to become 1,000 times, I'm replacing the 1 megabyte with a million bytes because that's my conversion factor. So times 1 million bytes. That's going to equal 1 gigabyte. I put this in a different color so you can see the substitution, right? So just to be clear, I replace this 1 megabyte here with a million bytes, like so, because 1 megabyte equals a million bytes. Boy, I wonder how many times I've said the word bytes in this particular problem. I hope you're not keeping count. Now I just need to multiply 1,000 times 1 million, and I will be finished. So 1,000 times 1 million bytes. Well, let's see. Let's just, since we're dealing with thousands and millions and we're a base 10 system, we can just count the number of zeros in total. So this will be 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 2, 3, 4, 5, 7, 8, 9. I'll put in commas. In other words, 1,000 times 1 million is a billion. And bring down your bytes. Equals 1 gigabyte. So there are a billion bytes in 1 gigabyte, and that's ultimately what I wanted to figure out. How many bytes are in a gigabyte? A billion. Well, I just need to rewrite this so it matches up with this here. So that's the same as 10 to the 9th power. Because when we're dealing with numbers like this, we can just count the number of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I can therefore say 10 raised to the power of 9. Now, hopefully you can see that matches up with D right here, right? 10 to the 9th, 10 to the 9th. And D is my answer. Now real quick, if this confused you, remember exponents mean repeated multiplication. This really means 10 multiplied by itself 9 times. 10 times 10 times 10, all the way out 9 times. And if you did that, you would get a billion. You'd get this back. So in short, my answer is D. Question 24. A new yo-yo factory is operating at 80% of capacity and produces 40,000 not 40,000, but 4,000 yo-yos daily. When the factory reaches 100% capacity, how many yo-yos should be produced each day? So my answer choices represent the number of yo-yos produced if the factory is at 100% capacity. Well, let's take this piece first here. So 80% capacity would be 40 yo-yos, or 4,000 yo-yos. Now watch what I'm going to do here. Let's cut this in half. Let's say instead of 80% capacity, it was at 40% capacity. So half of 80 is 40, so if I take half of this, let's take half of this. So this would be 2,000 yo-yos. Hopefully that makes sense, right? If it's at 80% capacity, it makes 4,000. If I take half of that, Half of 80% is 40%, so I take half of 4,000, which is 2,000. So if it's at 40% capacity, it would produce 2,000 yo-yos. Now let's take half of this. What's half of 40? That's 20%. So if I do it over here, let's do it over here. What's half of 2,000? That's 1,000. So if it's at 20% capacity, it produces 1,000 yo-yos. Well, it wants to know how many yo-yos are produced if it's at 100%. And I notice right here, that 80% and 20%, if I add these up, right, 80% plus 20% equals 100%. So I just need to add this and this. All right, and that'll give me 100%, and that'll be my answer. So 80% plus 20% is 100%. So when it's at 100% capacity, we'll add these two. 4,000 plus 1,000 is 5,000. So when it's at 100% capacity, 5,000 yo-yos will be made. And my answer choice that goes with that is D. Now again, I should have looked at my answer choices ahead of time and seen if there were any that I could have eliminated. I probably would have eliminated A, but that's a good habit to always do at the beginning. Question 25. An artist knows that it costs her on average $40 per painting to have frames built at a frame shop. She is taking 30 framed paintings to an art fair. If she sells each painting for $100, how many paintings does she need to sell to pay for the frames? Again, look at your answer choices. I don't see any off the bat here that I can eliminate. Maybe you can. There's a lot of stuff going on here, so let's just organize this in some tables. So let's start with one table like this. And this will represent the cost for her picture frames. And let's deal with that piece first. So it says it costs her on average $40 per painting to have the frames built. So let's put the price here. So the price to make a frame is how much? Cost for frame. Maybe I should title that cost for frames. So let's see, what's the price per frame? $40, right? What are the number of frames? How many frames is she going to have made and is going to take with her to frame her pictures? It says right here, she is taking 30 frame paintings. So 30 frames. So what's that going to cost her in total? Or how much is she going to pay? Total cost I'll put here. Well, let's see, $40 for one. There's 30 of them, so I'll multiply these two, right? 40 times 30 is $1,200. In short, to get 30 frames made, it's going to cost her this much money right here. Now let's make another table to represent the her sales. And I'll break it up like this. I'll put here sales price. I could title this too and call it her revenue or something like that. Let's put number of paintings that she sells. Number of paintings sold. And let's see her total revenue. So let's see here. What's the sales price for each painting? Is that right here? She sells each painting for $100. So I will put that right here. How many paintings does she sell? Well, that's the question. It says, how many paintings does she need to sell, right? I don't know this piece. This is a question mark here. And what is her total amount of sales? What is it going to have to be? What do you think? Well, look, if you're not sure, let's look back at the question. It says, how many paintings does she need to sell to pay for the frames? Well, the frames cost her $1,200. So she's going to need to sell $1,200 worth of paintings to pay for the frames. These two need to be the same, so I want to put $1,200 here. That's why you got to read that final question. So, how many paintings is she going to have to sell to get $1,200 back to pay for the frames? Well, hopefully you can see 3 is gone, right? I mean, if she sells 3 paintings and each painting is $100, $100 times 3 is $300. Hopefully you can see your answer is going to be B right here. She's going to have to sell 12 paintings, because if I put in a 12 here, right here, 12 paintings, $100 per painting, 12 times 100 is $1,200. And that will cover the cost of her frames up here. Question 26. You are not going to see a trigonometry question on here. This sample test I took off the HISET website, and I got permission to do these problems from HISET, but they put a trig problem on here. You're not going to see trig on this, so I can skip this. I'll show you something. If you were to run into a problem like this on some other type of test, I would eliminate a couple and guess here. I can show you real quick. I'm not going to go through the trig here to do it. It's not as difficult as it looks, but I'm not going to go through it. If you want me to in another video, write it down in the comments and I'll be more than happy to repost this problem. But let's just look at the question anyway, so I can show you how to use the process of elimination to deal with complicated problems. It says Naomi is looking at a flying eagle, as shown in the diagram below. Which expression represents the eagle's height in feet above the ground? So I want to know the eagle's height in feet above the ground. So here's the eagle right here. I want to know its height above the ground. This is the ground right here at the bottom. So basically I want to know this height right here. So this length here is x, right? From here to here is x. So it's going to be x plus this length. Plus this length here is, I got to include that because it's the whole length. So it's going to be x plus 5. Well, the x is going to be some stuff. I don't know, it's going to have some trig stuff in it. So basically another way to look at it is I'm going to have some stuff plus 5. So I know a plus 5 is going to be in my answer. So here's some stuff, right? But it's minus 5, so this would be gone. Here's some stuff plus 5, so I would keep this one. Here's some stuff plus 5, I would keep this one. And hopefully you can see I can get rid of D, because D is some stuff minus 5, right? Some stuff minus 5. I can get rid of this one. I'll circle this in red too. And E is some stuff plus 5. So I would have to keep E. So look, I just eliminated two answer choices. Now I can guess. I have a better chance of guessing. I would guess B, C, or E. For your information here, the answer here is E. But you're not going to see a problem like this on the current HISET test. Or I should mention this is great practice for GED Math as well. You will not see this on the GED Math either. Question 27. Find the cubic equation that has -1 and 2i as roots. You will not see a problem like this on the GED Math Test or the HISET Math Test. This is advanced algebra, deals with imaginary roots. I'm not even going to do this particular problem. I can't even see a way of using the process of elimination. I can tell you that the answer for this is going to be D. Now, if you want me to do this in a separate video, write down in the comments, show me how to do this particular problem, and I'd be more than happy to do it. But for now, let's just move on. 28. You could see something like this. It says, suppose the functions f of x and g of x are inverse functions. About what line is the graph g of x a reflection of the graph? Okay, we're dealing with reflections and inverse functions. When one function is an inverse of another function, it is always reflected over the line y equals x. That's something if you can remember, you can answer a question like this real easily. Whenever you have inverse functions, or let's just say graphs, not all graphs are functions, but if you have inverse graphs that are functions, the reflection will always be over the line y equals x, which is going to be D. Now let me just show you a visual again. This is x, this is y. This is a good thing to remember in math. The line y equals x is this right here. Pretend that's straight. This is the line, the graph of the line y equals x. That's something very useful to remember. I'm not going to get into detail, but it's just a diagonal line that cuts this way, right through the origin. If you have two graphs that are functions, let's say I had one graph like this. The inverse of this graph will always be reflected over this line y equals x. Always, when they're inverse functions. It would look like this. Let me draw that a little better. Something like this. So this piece is reflected over this line y equals x. And that's just something you need to remember. So if you don't get this totally, that's okay. If this is something you can remember and it pops up on the test and you see inverse functions, reflections, think the line y equals x. Simplify the following expression completely. You could see something like this. This is a little more advanced, but we can do this. Let me show you how I break this down. This says the square root of 3 plus 2 square root 5 squared. I'm going to rewrite this as follows. I'm going to write this piece 2 times because there's an exponent of 2. And exponents mean repeated multiplication. So I'm going to take this piece inside the parentheses, write it 2 times, and multiply it. So watch. I'm going to rewrite it like this. The square root of 3 plus 2 square root 5, and then I'll write it again, square root of 3 plus 2 square root 5, and I'll multiply them. Now, looking at these answer choices, there's not one or any that I see personally that I can eliminate. So I'm just going to do straight up algebra and do this problem. I'm going to multiply. These are actually called binomials. I'll show you how I'm going to multiply them as follows. I'm going to start with this square root 3 right here, and I'm going to multiply it by this square root 3. I'm not even looking at this piece right yet. And then I'm going to take the square root 3 and multiply it by this 2 square root 5. So let's do that. Let's take this square root 3, and I'm going to multiply it. I'm going to use an x now for multiplication. That means times. Sometimes I use a dot. So square root 3 times square root 3. So I did that first piece. Now I'm going to take this piece, and it's all addition here, so I'm going to bring down a plus sign now. Now I'm going to take this square root 3 times this piece. So it's going to be square root 3 times 2 square root 5. I'm going to put parentheses in just to make it easier to read. So first I took this square root 3 times square root 3 here. Then I took this square root 3 times this, 2 square root 5. I wrote it here. Continue to use addition because it's all addition. And now I'm going to multiply this piece times this piece and this piece times this piece as follows. 2 square root 5 times this piece, square root 3, plus 2 square root 5 from here times 2 square root 5. I will put parentheses around this just to make it easier to read. So for that last part, I went 2 square root 5 times square root 3. I went 2 square root 5 times 2 square root 5. And I wrote that here. Now we just need to simplify this. So I'm going to go step by step and show every step here. Again, for a problem like this, if you don't know how to do this, skip this. And in reality, I believe you only need about half the questions right to pass the HISET test. You don't need to get every one right. And I should have stressed that earlier in the video. But let me show you how to rewrite this. These both have square roots. So I'm going to write one square root and put the 3's inside. So that you can rewrite the square root of 3 times the square root of 3 as the square root of 3 times 3. I just wrote one square root sign and put both of these inside. Plus, okay, what I'm going to do now, there's really a hidden 1 here. It's not showing. I'm going to multiply the 1 times the 2, which is 2. And then I'm going to write one big square root sign and multiply the 3 and the 5. 3 times 5 is 15. I'll put that inside here. Now the reason I can do that is because this 3 and this 5 are both inside the square roots. So I can write one big square root and multiply the 3 and the 5. And 3 times 5 is 15. I could have shown my step here, but I'm kind of, as I go through, I'll go through this a little quicker. Let's try to multiply this out. There's really a hidden 1 here. So I'll multiply the outside numbers. 2 times 1 is 2. And then the numbers inside the square root, I'll make one big square root. And I'll multiply these two. 5 times 3 is 15. And plus, I'm going to multiply the outside numbers. 2 times 2 is 4. Square root of, well, what are the numbers inside the square root? 5 and 5. So 5 times 5 is 25. By the way, I'm going to change this 3 times 3 to a 9. All right. Now we're getting somewhere. What is the square root of 9? Remember, the square root means I'm looking for some number that when I multiply it by itself, I get 9. Can you think of two identical numbers that when you multiply give you 9? Well, it's 3. So the square root of 9 is 3 because 3 times 3 is 9. Plus, well, this just, you can't simplify this, just bring it down. And you can't simplify this one, just bring it down. Now watch this one. I'm going to bring down this 4. There's really a times sign here. What's the square root of 25 right here? What number times itself is 25? Well, it's 5, right? Because 5 times 5 is 25. So I brought down the 4. I brought down my times sign. The square root of 25 is 5. And what's 4 times 5? Well, that's 20, right? So I'm going to change this to a 20. Well, look, I can combine now. I can combine like terms. I've got this 3, and I have this 20. Let's combine those. What's 3 plus 20? Well, that's 23. So I'm going to have a 23 in my answer. So anything that doesn't have a 23, I'll get rid of. This doesn't have a 23 in it. This does. This doesn't. This does. This doesn't. Now I have a 50-50 chance of guessing. But what I'm going to do here is show you how to combine these. Look at this piece here, if you notice, right here. This piece right here. Read it this way. 2 square root 15s plus 2 square root 15s. How many total square root 15s do I have? I have 4. I have 4 square root 15s. It's like combining like terms. That's what I'm doing here. What I'm really doing is taking the outside numbers, the 2 and the 2, and I'm adding them. What's 2 plus 2? That's 4. And I'm just bringing the square root 15 down. I'm bringing this piece down right here. This piece. And this piece, I'm just bringing the square root 15 down because it's in common. Or I think of it this way. 2 square root 15s plus another 2 square root 15s. In total, I have 4 square root 15s. So my answer has to be, let's see, it's going to be D. Let's move on. Question 30. What is the solution of this equation? Now, if you're not good at algebra, you're going to want to guess here. And if you're good at algebra, you might be able to solve this. One technique you can do is plug in each one of these numbers for x, your answer choices, and see which one works. That's a perfectly legitimate way to do it. To be honest with you, this one's actually easier just to solve, so I'm just going to solve this equation. So it says negative 5 plus the 4th root of 7x minus 3 equals negative 2. Now, you can put up your Weiss wall. Remember, this equal sign separates your equation into your left side, which is over this stuff over here, and your right side, which is the negative 2. So the first thing I'm going to do is just move this negative 5 over to the right side. So I need to make this go to 0, so I'll just add 5. Negative 5 plus 5 is 0, so what you do to one side, you do to the other. And this will go to 0. I'll bring this down. The 4th root of 7x minus 3. Bring down my equal sign. And what's negative 2 plus 5? Well, think of temperature, right? If it's 2 below 0 and it goes up 5 degrees, you'll be at plus 3 above 0. So this is 3. Now, I'm going to rewrite this because I need a little more space. I'll show you in a second. Well, actually, no, I don't. I'm going to show you a little trick, actually. This 4th root right here, I want to get rid of this radical symbol right here. This is called a radical symbol and the 4. So here's a little trick. You can just take this 4 right here and turn it into an exponent with the 3. So just put this here. And when you put this 4 over here and it becomes an exponent with base 3, this whole thing drops off, the radical and the 4, and you're just left with 7x minus 3 equals 3 to the 4th power. Well, what is 3 to the 4th power? Remember, exponents mean repeated multiplication. So this means to take the 3 and multiply it by itself 4 times. 3 times 3 times 3 times 3. That's what this means. Now, when you're multiplying, you can put parentheses wherever you want to. So I'll put it here and here. 3 times 3 is 9 times 3 times 3 is 9. 9 times 9 is 81. So this becomes 81. And now I just need to solve for x here. So I need to move the minus 3 over to the right side. So to undo subtraction, I do addition. So I want this to go to 0. Minus 3 plus 3 is 0. What you do to one side, you do to the other. These drop off to 0, and we have 7x equals 81 plus 3 is 84. And this means 7 times what number is 84? Well, it's going to be, let's see, is it 3? No, 7 times 3 is not 84. It's going to be this one right here, E. You can go through each one of these and see that when I plug it in for x, it doesn't equal 84. 7 times 12 equals 84, or you can just use division. divide both sides by 7, and you can get out your calculator and go 84 divided by 7, and x equals 12. So E is my answer. Question 31. What equation represents relationship that S is directly related to R and inversely related to T? So watch, I'm going to show you some examples of direct relationships. First of all, it says S is, right here, S is. Is, in these types of problems, means equals. So S equals something. These are direct relationships. That's an S, by the way. S, and it's directly related to R. So like S equals 2 times R. S equals 8 times R. S equals 1/100th. You can even have a fraction times R. The point is, I'll do one more. I don't know if I should have put this one. I don't want to confuse you, but it works. These are all direct relationships. S equals 5R. Direct. Now, indirect relationships look like this. Again, we're going to have S equals. So S equals, and it says inversely related to T. So the reason I used R here, because it said it was directly related to R, so these are direct relationships, but it's inversely related to T. This is what that would look like. 2 divided by T. 8 divided by T. Let's not worry about this one too much. It's easier to see with multiplication. S equals 5 divided by T. What you should notice is with direct relationship, the R is on top. We're using multiplication right here. But with indirect relationship, we're using division, and the T is on the bottom. So the T is on the bottom on all of these, and the R is on the top. Which one has an R on the top, where it's in the form S equals R on the top and T on the bottom? Which one? This one, R and T are both on the top, because I could put a 1 down here if I wanted to. I could put a 1 right here. So this doesn't work. I need the R on the top and the T on the bottom. Here, the T's on top, R's on bottom. This is backwards. Looks like it's C. Because the R is on the top and the T is on the bottom. R on top, T on bottom. Now let's make sure we understand why D and E don't work. As you can see, with answer choice D, the R and T are both on the bottom, so that's gone. E's a little trickier. The reason this doesn't work is because we have addition. And whenever you're dealing with addition, it does not represent direct or inverse relationships. So the reason E's gone is because of this addition sign. So in short, when you see directly related, think multiplication, R on top, and when you think inverse relationship, think division or T on bottom. Well, thanks for watching my video. I hope this was helpful. If you watch the whole thing, that's great. That shows a lot of perseverance, and my goal is just to help you build your confidence in math and to learn test-taking strategies and also understand concepts. And these together will help you manage your time and boost your confidence. And I really hope you do well on any test you take, whether it be HISET, GED Math, or any other math test you have to take. And again, these problems will help you with a wide variety of math tests. So thanks for watching my video. Have a great day.